All right, before we get started, go ahead and write down the learning target for this lesson. We're going to talk about inverse and joint variation is what's in this section, but we're also going to go back and talk about direct variation too. So at the end of this lesson and the lesson in class next time, you should be able to construct and solve an equation using direct, indirect, or joint variation. And we're going to just kind of do an introduction in this video, kind of talk about the basics of each one of these things, and then actually apply them to some real-world situations in class. So we're first going to talk about direct variation. So go ahead and write this down, that x and y denote two quantities. So we have two quantities that we're working with, and we can say that y varies directly with x if there is a non-zero constant k such that y equals k times x. So you'll notice that this is basically a linear equation where the slope is that constant. We don't have any y-intercept. So when two quantities are directly, if they vary directly with each other, then our starting point is always 0. We're not going to have that y-intercept. So y equals kx. All right, so let's use this. Write down this example. So please write down the example because we'll come back to this in class. Suppose y varies directly with x. Okay, so we're given that information that we have a direct variation problem. We're going to be told one just isolated piece of the whole picture. So we'll say, okay, well, we know the information we're given is we know that if y is equal to 3 when x is equal to 9. So we want to use that to come up with a general formula so that we can find any x or any y if we know the other. So if I know that y is equal to 3 when x is equal to 9, I first want to find a general formula that's going to relate x and y. So go ahead and write that down. Find a general formula relating x and y. So we are told that y varies directly with x. That's important because we know that the formula to use is y equals kx, that this is going to be a linear equation with no y-intercept. So we know that y is 3 when x is 9. So I can use that information, y is 3 and x is 9. I can solve to figure out what that constant is, so that no matter what, in this situation, our constant value is going to be 1/3. Okay. That is how x and y are related to each other. So our general formula, y equals 1/3 x. So y varies directly with x. They're related to each other. Y is always going to be 3 times more than x, or x is always going to be 1/3 of y in this situation. So we can use that. Once we find the general formula, now if I'm given an x, I can find the y that corresponds to it. Or if I'm given a y, I can find the x that corresponds to it. I can figure out something else that has a similar situation. So what is y now when x is 21? So we have our general formula, y equals 1/3 x. So I'm trying to find y when x is 21, which means y is going to be 7. Okay. Okay, so inverse variation. Write down this definition. Let x and y denote two quantities. So again, we'll just have two values, two quantities. Could be anything. And we'll actually look at applying and some actual instances of quantities that have real-world application. So if we have x and y denoting two quantities, then y varies inversely with x if there's a non-zero constant k such that y equals k over x. So we're varying inversely. So before we had y equals k times x, okay? Well, the inverse of x is 1 over x. So now we have y equals k times 1 over x. Or in other words, y equals k over x. Okay, so y and x vary inversely with each other. Okay, so write down this example, please. Suppose y varies inversely with x. So we're being told that information that they're varying inversely, so we know what to use. And we're given one example of this situation. We have y is equal to 12 when x is equal to 5. So we want to be able to find out some general formula. How are these two related so that I can use that every time? So since they vary inversely, I use y equals k over x. So I know that y is 12 and x is 5. So multiply by 5 on both sides. So that I can cancel out my 5 and solve for k. And I get k equals 60. Okay. So my general formula, oops. Now let me rewrite that really quick so we can write that down. Got a little ahead of myself and knew exactly what we were going to need to do. Okay, so we're finding a general formula. So y equals k over x. So we have 12 equals k over 5. Multiply by 5 on both sides. And get k equals 60. So our general formula, so finding that general formula so that we can use it to find any x or any y in this situation, we get 60 over x. So in this particular situation, to find x and y, I always need to take 60 divided by whatever my x value is. So what is y going to be when x is equal to 2? So we can use our general formula now. So we have that y equals 60 over x, which represents this particular situation. So in this particular situation, when x is 2, y is going to be 30. Okay, so we have direct variation and we have inverse variation. The last one we have is joint or combined variation. So please go ahead and write this definition down. When a variable quantity q varies directly with the product of two or more other variables, we say that q varies jointly with these quantities. Okay. So when a quantity varies directly with the product of two or more other variables, we say that q varies jointly with these quantities. So if we have a combination of direct and inverse variation, this is usually referred to as combined variation. So combined variation means we have both direct and inverse variation in the same equation, in the same problem. So it's a combined of the two of them. But you'll notice in joint variation, this is still a type of direct variation, but you have two or more other variables. Okay, so instead of just one. So for example, you might have q equals k times m times p. Okay, let's say our k is 3. Okay, so there's your constant variation. But since q varies directly with both m and p, then we call that joint variation because q varies directly with two other variables, the product of two other variables. Okay, so joint variation is just another example of direct variation. We just have two or more variables instead of just one that are related. And then if we have direct and inverse all in the same problem, we call that combined variation. So in class, we're going to do some examples of real-world problems where we can use direct, inverse, and combined variation problems. So please make sure you have all those definitions written down and those basic examples, because then we're just going to jump right in and use those in class.